2015, where two people hacked a Jeep with people in it driving on the highway by using their computers the side of the road. There's pretty cool videos online of that. It was hand controlled, but it still feels a bit shaky when you have people in the car. But this is actually something that's becoming more and more of a, well, maybe not a problem yet, but at least a concern from the vehicle industry. And the reason is, I would say that today a truck or a car has a lot of IT components and become more and more dependent on this. And just maybe a few years back, maybe they weren't connected to the internet or something like that, but still have a lot of software and hardware. And one problem is we see now with these kind of 5-year-old cars. And we release a special dongle which you can connect to your car, to the OBD2 port. And nothing in the car was designed for security because you weren't supposed to connect the car to the internet. That port was for, I don't know, going into the shop and getting maintenance and stuff like that. But now Telia released a dongle so you can do 4G connection directly into the canvas, basically. And then of course, if Telia does this, other companies will follow. So there are now cheap Chinese dongles to buy a battery from. So you can connect your old car, which is kind of cool, but yeah, we haven't seen the effects of that yet. But then today, of course, if you buy a new car, it's basically connected to the internet. And if you look forward, we're talking about the self-driving cars. And you were talking about, they're coming here in 2 weeks and talking about the bus and cheese stuff. Yeah, so that's really cool. So, yeah, so the car industry or the vehicle industry is becoming more and more dependent on IT. And then security becomes one of the main concerns. I'm going to tell you a little bit why this is so difficult to handle, both for a car, but also kind of in general. So what you see here is a matrix, and what you have on the rows and columns are files in one software. So this is Google Chrome, and these are all the C files in Google Chrome. So it's almost 65,000 C files for one web browser. And the dots here are dependencies between the files. So all these thousands of files are very, very heavily dependent on each other, which makes it really, really tough for the software developers to make changes without doing any mistakes, because they can't really follow all these dependencies, especially if you start looking at not the direct dependencies, but in the second and third line of dependencies. And what we've seen for a very kind of a simple software like a web browser is that where you have the most dependencies, that's where you find the vulnerabilities, the security issues. And we think that it's because of the complexity. So people can't deal with this type of complexity. And if you then look at kind of a system-of-system level, where you have multiple softwares dependent on each other on the next level, or dependent on other IT components, you get a really, really huge kind of cloud of dependencies between software. So on this level, everything is dependent on everything, and then on the next level, everything is dependent on everything. And this makes it really, really tough for people to handle. No one or a team of experts can't really handle this complexity. You need the help of computers to deal with it. What you see here is something we call attack graphs. I will talk more about that a little later. But basically, the dots here are possible attacks, and the edges between them are all the attack paths then between different components in a system. And the colors here indicate how fast you can succeed with an attack. So all the kind of purple, red, pink dots are attacks that are easily done. So one possible solution to handle this complexity is to use models. Models to abstract this complex reality into something that's more easily understandable. And depending on what field you're in, you can call it different things. So software architecture, system architecture, and on an enterprise level, we talk about enterprise architecture. In the security field, it's threat models, basically. But they're all very closely related and they use kind of the same concepts. And the idea is to use these models to understand the reality, but also to make different types of analysis. And in the end, improve, make a better design or make changes to improve the architecture. There are some problems with it. And the main thing, at least in the kind of IT field and enterprise architecture field, is that right now everything is dependent on manual expertise. So even though you have these models or this modeling concept, you use human experts to create the models, to analyze the models, and to make changes to improve things. So you're still very heavily dependent on these experts. If you look at more mature engineering disciplines, and I think that most of you have a background in this, you use computer-aided design, CAD tools, to help you when you have these complex architectures. Designing a car in a CAD tool and testing, well, what kind of changes should I do, and then analyze it, I don't know, in wind tunnels, in the tool, or whatever. You can do that. But for IT and for security, you don't have that. So that's where we kind of come into play. That's our idea. Take these CAD concepts that more mature engineering disciplines use and use it in the IT and the security field. And the problem has been that, so this is an enterprise architecture model. This is from a company. This is their kind of software portfolio. So I go to them and they say, well, yeah, we have an architecture model. We can show you it. Okay, here are all our software systems and how they depend on each other. Yeah, and it's good to have this. Most companies, they don't know what software they have or how they depend on each other because usually they have thousands of them. But some have it. The problem with this is, how do we know if this is good or not? Well, it really depends. If this can be a great architecture, depending on what you're looking at. I don't know. And the problem is they don't usually either. They just document it. They just use it for documentation. Well, this is what we have. And then if they start a project, they might bring it out and say, look, this is what we have. We want to remove this one. Let's see what happens if we remove it, and then they try to follow it. But it's very, very, very idea when they created a model what they're going to use it for. Because if you have a model for handling, I don't know, performance issues, that might look very, very different from a model where you want to look at security. When you talk about security, you have the information security officers, and they spend every day thinking about, okay, I have this very, very narrow budget, and security is crap, and there are thousands of things I can do to improve it, where to start. Could be anything from sending my staff to training to raise awareness. Don't install fishy software on your computer when you give a talk at strange places. Or should we do network scanning, for instance? Or should we make sure that all our hosts are hardened? There are a lot of decisions to make. And the problem is that the tools that we have today, they don't really fix this. There are certain things that help with very specific tasks, which is good. I don't say that the tools that are out there are bad, it's just that there's something missing. So for instance, a vulnerability scanner, it doesn't really catch all the vulnerabilities, and it only looks at things that are known on the things that you look at. And they can tell you about one technical vulnerability. Okay, we have a software vulnerability over here, but it doesn't say anything about how that relates to other parts or if that can be used to reach some of your critical assets. So it's good, you know what vulnerabilities you have, but you don't really know what to do with it. And often you get thousands. If you run a vulnerability scan in a company, you get thousands of vulnerabilities. So where should you start? And you don't get that help. One thing that's quite common in, at least when I've been talking to Scania and Volvo and so on, is that they have these penetration testers, ethical hackers. They have people that do hacking. So when they have a lab and they start think about new software or IT solutions for up and coming cars or trucks, and then they have experts, ethical hackers, trying to penetrate that kind of infrastructure in the lab to see, okay, what problems are there. So this is really, really good. The problem with this, it's only valid kind of, well, you need to find the expert first, make sure that they know what they're doing, which is quite hard today because there's quite a few people with that expertise. They are expensive and they tend to move between companies, so you lose the expertise quite fast. Any changes they have. And another problem is that you saw the graph with all the possible attacks. If you're one person trying to do those attacks, maybe you can manage to do a couple of them in a few days, or I don't know, 20 of them in 2 weeks. But there are thousands of them. So how do we make sure that these ethical hackers do the right things? So kind of handling security today on all levels, for even if it's for a car, for one software, or for an enterprise, there's a lot of things that makes this really difficult today. I've been talking now about the growing complexity and the kind of the increase in dependencies, but there's also, I mentioned the shortage of skills, and right now if you go to a company, security is on the highest level. The board and the CEO and everyone are concerned about security, so people working with security get high demands from the C-level. And then also there's quite a lot of external pressure. The number of threats is constantly increasing. It's not only human attacks or human hackers that you're afraid of. It's robots on the internet just trying to do everything, just probing and looking for holes to get into your car or your enterprise. Whatever that's connected to the internet, they're trying to get automatically all the time. And what we've seen is no one is spared. You can look at a very, very small municipality in Sweden, and they have attacks going on every day, or small electricity companies up north. Everyone is affected. And now we've seen an increase in laws and regulatory demands. Now with the GDPR, the new European law in privacy, and so on. So there's a lot of things going on. So this is becoming a really, really important topic. I usually get the question about different types of attacks. So someone says, well, there's new attacks all the time. There's new types of attacks. How can we be, on top when the attackers come up with new things all the time? Well, that's not really true. The attack types, the things that people are trying, the same thing that we had 7 years ago. If you look at the top list, in 2010, 5 of the top 10 attacks are the same as last year. And the other 5 that were new on that list, it's not really new things, it's just that they popped up on the top 10 list. So you can really predict what type of attacks that are most common, that you will be set under pressure from. So you can't really use it as an excuse to say that, well, the attackers, they come up with new ideas all the time. They don't. They just use known vulnerabilities. It's your job to make sure that you don't have these known vulnerabilities. You look at you remember, I think it was last year, this ransomware was hit like millions of computers all over the world. And it was a known vulnerability in Windows. So if you had patched your Windows systems, you weren't affected. And that had been known for several months. So the problem wasn't that this was something new and unknown. The problem was that people didn't, either they didn't know that they were supposed to patch, or they didn't know that they had critical assets that could be affected by this. Because something, you have thousands of vulnerabilities, you can't fix everything, but you need to fix the things that matters. So that's something that you need to figure out.
What's the headline here?
Huh?
What's the title of this slide?
OWASP. That's I don't know what that stands for. It's a security kind of not standard, but it's a security organ that does different types of kind of research, not academic research, but industry research. So
Open Web Application Security.
Yeah, no, but so yeah, they do this kind of looking at different top lists and stuff like that. But this is just to show you that there's not new things going on. It's the same things that it's been going on for 10 years. For some, make sure that thing is under control once you start building it, and that's because that discipline is mature. You know that what materials, what kind of effects it will have if you choose a certain material or a certain thickness. They have theories that everyone agrees upon. That research has been done for many years, so it's not strange that you have it. So it's a mature discipline, while IT and security is not mature yet. But I think we're getting there, and I think we need to look at these disciplines to learn. So we need to find these kind of security theories that people agree upon. So what we do in our tool and what we're going to do in this project, we have this threat move project. So it's KTH and this spin-off for City, and it's Volvo Cars and Scania, and also a other security company called F-Secure. So what we're going to do is we're going to do this CAD simulations for vehicle IT to basically simulate attacks, and in the end try to improve security. And these simulations, they're built on something called attack trees or attack graphs. So it looks something like this. This is a simple example of not a IT compromise, but rather something you all can relate to. It's someone wants to break into your house. So what can they do? Well, they can either go through the window or through the door. Those are two possible attack paths to break into your house. To be able to get through your door, you need to get access to the door. You need to stand basically outside the door, and you need to bypass it. How can you do that? Well, you can either use a key, if you stolen the key or found the key under the mat or something, or you can use an axe, or you can pick the lock if you're a good thief. Then there are defenses related to this. So if you have a door made out of steel, it will take much longer for the thief to use the axe. And if you have a really good lock, it will be, well, maybe not impossible to pick it, but it will take a lot of time. So the only option is to maybe not find it. So these kind of graphs can take this into consideration. Different types of attacks, how they relate, and different types of defenses. And what we've been doing in our research is trying to figure out then, well, if we have a door made out of steel, how much longer will it take for an attacker to go through that door using an axe? Well, maybe infinite. And then we use Bayesian networks, so basically statistics where we collect this information, and then we can calculate, saying that, well, if we have a thief here and they want to break into our house, we can basically simulate that attack and see how long will it take to do that step, and then that step, and then that step, based on the defenses that we have. We haven't been doing it for breaking into a house, but for IT. So we've been collecting these statistics for different types of IT attacks. One thing that we did with the Swedish Defense Research Agency was that they have a lab. It's kind of like the IT of a small power utility. And then we had two teams of Estonian hackers trying to break in and capture different flags in the infrastructure. And then we can monitor that and see, okay, what kind of attacks do they try? What kind of defenses do we have? And how will that affect their choices? Maybe they give up after a certain time and try something else. And yeah. So that's one way of collecting this information. And in the end, what you would get is a graph that looks something like that. We call it TTC, time to compromise. So it's the probability of a compromise, and then it's the time. So how long time will it take to what probability? So we can then talk about someone's IT architecture and tell them it will take this long for someone to succeed with this type of attack.
So by you placing the flags, are you like sort of biasing what kind of attacks they will do?
Yeah, kind of, but we need to have some kind of controlled environment. If we don't have any flags, then they don't have a goal. We need to tell them, we need to give them some kind of goal. So the flags are just saying that, well, here there will be a critical asset. Maybe something like a breaker in the power system. So if they reach that breaker, they get a point. So
there's some point to each of the flags.
Yeah, exactly. Yes. So if we would do this something similar for a car, and that's what we want to do in this project, we're looking now to buy a car, and then to have people do different types of attacks on it, depending on what kind of IT we have and so on. And in a car, you could have, well, someone just setting the, I don't know, the linkage, what's that called? The signals to the left, for instance. Well, that might not be that critical, but it could be interesting to see if that's possible. But I don't know, pushing the brakes or steering, using the steering wheel, that would be a very critical asset. So we would like to see.
Are there any solid methods to control for the unknowns in this conflict?
Yeah, well, yeah, it is. So using Bayesian statistics, you can always add an unknown. We don't know this, and then depending on what kind of information you have, you can give that more or less weight, I would say. And then in the end, if you know very well, there are unknowns on different levels. So there are unknowns in the statistics, but also with your infrastructure. Maybe you don't know exactly what you have, and it's been difficult to map it out. Or for instance, the patching thing. Well, maybe you had everything patched 3 months ago, but today you don't know. Maybe some of them are patched, but not all of them. So you can then decrease your certainty on the patch level. You can say that, well, I'm 70% certain that everything is patched, but I'm not sure. So you can take that into consideration.
Or maybe just like I was thinking of other potential threats that could happen.
Yeah, of course. So here, for instance, the breaking through the window and the door, there might be a third and fourth and fifth option. There's always someone in the audience saying, well, what if someone lands with a helicopter on the roof and sets off a big bomb or whatever. Yeah, you can take that into consideration. We don't spend that much time thinking about that. So because we feel that we've been doing research for, I don't know, more than 15, 20 years with a lot of people. So we have quite a good idea of the types of attacks. And as I showed you with the OWASP thing, that the type of attacks, they're quite stable. So it's quite easy to say that, well, compromising an IT asset like a service or something, there is a kind of finite set of attacks that are possible. Then we might not know all the statistics behind every attack, but we're quite sure that we've covered the attack types on that level.
So, one more thing. So you were talking about attack paths, so different actions that these attackers are performing, like in a sequence, but because you were mentioning a graph that is a lot of interconnectedness and so on, and all the system components, is it possible that you have attacks that require multiple paths and interactions between them and so on?
Yes, exactly. That's exactly what we want to help with. That's what a person, an expert, have a hard time knowing.
Yeah.
So one thing that we look at, we try to identify them critical paths. So in this big graph with thousands of options, going from one point to another, which is the most critical way that an attacker will use. And we look at that by simulating thousands of attacks. So we use like Monte Carlo simulations on these graphs, trying to see, okay, they try once, then they do this, they try a second time, then they try this, and then we accumulate that information. And we present it on a way like this, saying that, well, this is the most critical way in, from going from maybe then the internet or maybe from the ODB port to the steering signal or something like that. And the thing that we want to show with this is that, because people say that, well, if I do this vulnerability scanning, for instance, then I know what vulnerabilities I have. The problem is you don't know how they relate to each other. So we call it structural vulnerabilities, which is then a combination of these kind of known technical vulnerabilities. We've seen in studies that most attackers, they don't use always the most critical one, according to some metric that is out there. There's all kinds of metrics, but they often use a combination of lower level kind of criticality, but together that will create a much bigger impact. So that's what we are trying to highlight, that using these graphs, what we can find is how these vulnerabilities relate or interrelate with each other to create this critical path. And the thing is, so maybe I can draw here. So what we do in the tool, maybe I can show you here, but basically what we do is that you can, as an expert, you can draw like, okay, here I have a component which is related to another component. Could be a protocol or a network or a host or whatever. And then we have in the background, you don't have to say anything about it, but we have a number of attacks here on this type of component and defenses. So you can say that, well, I have a service here and I have patched it and hardened the host or something. What we do when we run the simulations is based on this kind of entity relationship model, is that we generate automatically this huge graph of all the possibilities. So that's what you will get out. So in the tool, you basically choose, here you can see a list, you have the clients, data flows, firewalls, hosts, networks, the IT infrastructure basically. So you can create a model, either as an engineer, you design something new, you drag and drop, and then simulate and automatically generate these attacks. Or if you have some infrastructure that's already in place, what we can do is we can take these vulnerability scans, for instance, or firewall rule sets, or if you have a database with inventories of your IT, we can use that information and automatically populate this model. So you don't have to start from scratch. Then you can get, okay, this is what it looks like today. Now I, as an engineer, I can make changes that I think are relevant, and then I can see what kind of effect that will have on security. Did I worsen everything now by introducing this new thing, or did I improve it by segmenting the networks or introducing a new protocol or what it could be? So that's the idea with the tool. So in the project that we are starting now, that's related then to the vehicle industry, what we want to do is we want to take this tool, because this is mostly now tested on SCADA systems and office networks. So that's kind of one type of IT, or two types of IT. But if you look at vehicles, there's a lot of special or kind of specific protocols and techniques that are used. So what we need to do then is, well, we need to update or get updated statistics on those. We don't know about all the vehicle stuff. We know in general some stuff that we can reuse, but not the specifics. So we need to do these kind of studies. So that's, for instance, F-Secure, that's in the project. They have these penetration testers. So the idea is that they will try to hack, for instance, a Scania truck. We have master thesis workers and bachelor thesis workers trying to find vulnerabilities in these Telia dongles, for instance, or stuff like that. Basically trying to build a library of more vehicle-specific components. So we have some people trying to use the tool as it is right now, building a car IT infrastructure and simulate attacks. But that would be, those results would be then lower certainty about the results. I think you can still find attack paths, but the level of certainty in the results graph might be lower. I think.
Is the communication network also different? I mean, in terms of like opportunistic networks or something in V2I or whatever, is that also a factor that influences?
Yeah, I think so. I think all these new or special technologies that are used that are not common, they can both be, well, people who want to do hacks or attacks on it, they need to learn that technology, so that might be an obstacle that helps, but also since the other things are so well known and used, there's people testing it all the time, so security increases. If you have more specific technologies, you have less users and then less testing of it, kind of. So there's two levels, but I think, yeah, we need to consider that, I think. And I know that, well, all these companies, they are trying to figure out what technologies to use. Should we use Ethernet, for instance, or should we, yeah, so there's all kinds of ideas. And this is one way of kind of prioritizing in what order to do the technology. So if instead of buying new stuff and putting it in the lab and having people test it, you can first simulate it and then say, okay, maybe that wasn't that good of an idea. We let's try this first, and then so this can help them prioritize the work, I think. Yeah, well, based on the tool, you can get all kinds of reports out of it. So one thing we look at is risks. So, for instance, you can get this risk matrix. Basically, what this would say is that if someone managed to do the attack, then there's a big consequence, and since we calculate the probability, we can say something about that. For instance, the red one would be high probability, high consequence. So, while if you would be down here, it would be low probability and low consequence. So maybe you don't need to care about those risks right now. You should start in that upper corner. We have some reporting called choke points. Basically, it tells you what parts of the IT infrastructure is mostly used in the attacks to your critical assets. So are there certain points where all the attacks converge? This is where everyone gets to, and so that could help you also prioritize if there's a certain thing you need to fix. And we can give some kind of suggested mitigations. So we can see if that, well, you haven't patched this for a long time, or you haven't hardened this, you have unknown services running. So maybe you should do that first. Simple things that can make a big difference. Yeah, and we've been working with quite a lot of companies. Well, before we head into the vehicle industry, we've been working with Klarna, for instance, in banking, and especially looking at, they're using Amazon Web Services and the cloud for a lot of things, assessing the security of that and their kind of connections to the Amazon Web. ABB and their SCADA systems, and also we've been working with Solve, for instance. So those are some of our partners and customers. I have some, I don't know how much time we're spending. Is it?
Can continue a little bit.
Yes. Well, you have stopped me for questions, so continue asking questions if you have them. Basically, for vehicles, cybersecurity equals safety. But it's a big problem that if you have these security vulnerabilities, that could mean loss of lives, people getting hurt. So it's really, really important. And the problem has been in other industries, and we don't want the vehicle industry to end up in the same situation, is that most of the time and money spent on reactive security, basically putting out fires all the time, so they never have time to think proactively, thinking about, okay, what should I do to make it more secure, but rather just, oh, we need to fix that, we need to fix that. And the problem with proactive security, as I mentioned, is that it's dependent on manual expertise. We need to get into getting help from computers. They can do a a lot of work that we can't do, and they can really help with that, simulating stuff many times, all the time. Yeah, so threat modeling. I found some papers and reports on using threat modeling in the vehicle industry. I'm not how many who work with like cars and trucks? It says transport, but that could be a lot of things. Cars, how many are car people, kind of? Little bit, not that many. And trucks, or is it, what the rest of you, is it trains then, or, yeah. The problem with, if you look at using a technique like threat modeling, there are some people trying to do that for in the car industry, so it's not just us. The problem with most of these threat modeling approaches is also that they're still quite manual. There's this free tool from Microsoft called Threat Modeler, which is basically something you use to design new software and make sure that that new software is secure. But that's very manual. You do the modeling manual, and then you need to analyze that model and see, okay, what could be wrong with this one. You get some hints, but it's very manual. And we think that you need to go into the more of a automatic version. So we think that there's a big gap here. So the vehicle industry, they don't have any of these tools. So we think that we can help them. And basically what we want them to do is create these models. And I think now when they're designing new cars and new trucks and so on, it will be quite a lot of manual modeling. Okay, we're trying, let's do this change. Let's see what happens with this technology and so on. But then what we can do in the next step and help out with is the simulation of the attacks and also the analysis. Okay, what happens if we do this and that, and help them make decisions.
What specific things are in this vehicle-related systems that makes, let's say, the current ways don't apply to them?
I would say that, well, one thing is that there's a lot of development going on. They haven't decided yet on all the IT technology, what to use, what should become the next standard. If you look at Office IT or something, it's more or less the same technology. It's on chips. But now with IoT, and they want smart cars to be connected all the time, and in the end, autonomous driving and so on. So there's so much going on, and right now they don't have any idea for how this will affect all these dependencies. How will this affect or something? The other thing is there's so much pressure. They have their own protocols. They have their own standards. They have their own. Everything is kind of contained there. They don't use the same things as they do in banking or in data systems. If I look at the systems that ABB does for SCADA and power, they have more similarity with banking systems than vehicle systems have with SCADA systems, even though they're both control systems. So I think the vehicle industry is kind of special. Everyone says they're special, but I think the vehicle industry actually is. That's my interpretation.
And in terms of these are often threats which you have identified before, kind of like with methods as well, but there's been also talk about zero-day exploits. Do you know how vehicle manufacturers can handle those, or maybe they have thought about dealing with that?
0 days is always difficult. 0 day is basically a vulnerability that only someone has found out about it, but the public doesn't know about it. So you have a vulnerability, but you don't know about it. That's basically a 0 day. So it's difficult to take that into consideration. I think that what you can do with a tool like this is that, so if we look at the ransomware that I mentioned, where this window vulnerability occurred, so it was a 0 day for a short point of time. But even it became known, people didn't do anything about it, because they might still not know about it or what kind of effect. What we can do in a tool like this is that if you have this graph, and then you have certain probabilities here on attacks occurring, what we can say is that, well, if there is a 0 day here, what effect would that have? So you can do some kind of proactive measurement, saying that, well, if this is a really critical asset, steering the car, we don't want 0 days to be able to get to that. So we need to think about ways to kind of break it, or if we, as soon as we know that there is a 0 day, as soon as it's known, we need to fix it because it's connected to this critical asset. If it had been connected only to something non-critical, maybe it's not that urgent, so we can wait. But as long as we have connections here, we need to do something. So, and what we can do in the tool is, as if you model an operating system in general, we can say, well, we can say something general about how often new 0 days occur. We can say that, well, for any operating system, every month there's a new 0 day. But if we know that we're using Windows 7, we know that there's a new 0 day every 13th day, while if you use a Linux system, it's every 3rd month. So probabilistically, we can say something then about the occurrence of a 0 day here, depending on what technology you're using. So now it's been 3 months and you have a Windows system that you haven't patched. It's quite likely there is a 0 day, even though, well, since it's a 0 day, we don't know about it, but statistics tell you that there probably is one. So you can use that kind of analysis. I don't think you have that many slides that we haven't really talked about. No. Yes, any more questions?
Not so much of a question, but more of a comment. I think there might be other outside the technical scope. I think there is a motivation for this.
Mm-hmm.
There's money in breaking car and car infrastructure.
Mm-hmm.
I was thinking about this shipping of cars. Is that a cybersecurity breach, or is that an enhancement, and who is in control of that? Because basically, if I chip my car, maybe it's getting illegal for, I don't know, exhaust regulation. But maybe it's not. Maybe it's actually improving my car.
Yeah,
so I think if we push this out to a general public, we will see abuse, misuse, disuse, and all kinds of moderations.
Yes.
And of course, there's malignant ones, but I'm not sure that completely securing it is even an option. That's, I don't know.
No, I think that you can't stop everything, and that we've seen. It's the same with breaking into a house. You can do all kinds of measures, but if someone really want to break into your house, they will do that. They steal diamonds from the bank vaults in Switzerland all the time. So, even though they're really secure. So, I think getting something 100% secure, it's not possible. So, but those are scenarios that Scania and Volvo are talking about. Not only the evil person on the internet, but rather maybe actually the owner of the car or the truck. Breaking into the IT to do changes. I don't know, truck drivers, they don't want to stop and sleep as often as they should. Should they then use the IT infrastructure to make changes to that?
What I would like to see is a bit of a monitoring. The status that you want your vehicles to be in, more or less. And I think if you're monitoring this online, if you have the infrastructure to monitor this and allowance to do that, I think you can find out a lot of things. You will establish the patterns that are possible, and you will see outliers. And once the outliers become known, I think then it's interesting to look at what's happening here. So I would.
Yeah, no, I agree, and I think there's a lot of different things going on there. I know the insurance companies, they're looking at this. So if you allow them to monitor your car and you never break speed limits and so on, you get a lower insurance rate, for instance. And I think car manufacturers, they might do similar things. So yeah, but then it's a privacy issue. Not everyone wants everyone to know where they are or how fast they're driving or how many people they have in the car and so on. So I think it's going to be the same debate as we had with, I don't know, cameras in the subway system and so on.
Do you think there's a trade-off in accepting the automation of connected vehicles, that we just have to accept at some point that there might be a case where your car gets breached or
something happens because of this increased connectivity?
I think that close to now, I think there's a lot of things gonna happen because I think that we connect things and increase the kind of technology level in vehicles very rapidly. So I think there's going to be quite a lot of bad things happening before we become mature. So I would think twice before buying a new car and having it all connected. But as we saw with the G-Pack, right now it's really simple. You know, there are tools that are free online that can help you hack anything. If you just want to, you can do it. So.
Is Jeep worse than other cars, or have they made similar demonstrations on different brands?
Yeah, probably. They're probably not worse than other cars. I know there's been quite a lot of legal cases in the US where you have researchers hacking a brand and then telling that manufacturer that, well, we managed to do this on your car, and they realize that, well, we need to withdraw millions of cars because of this. We need to have everyone into the shop and then update something or whatever. So they've been trying to stop the researchers from publishing the results because they don't want to, you know, they don't want this to become public because it will cost too much. So there's a lot of cars out there with known vulnerabilities, but the car manufacturers they don't fix it. So there's been several cases. Luckily, the researchers have really persisted, and yeah, now it is known. But there was a law in the US that you weren't allowed, even as a researcher, to buy a car, and even if you own the car and you do it for research, you're not allowed to hack it. That was an American law up until I think last year or 2 years ago. So now they've changed. So now as a researcher you're allowed, but under very specific terms on how to report what your findings are. So it's a big not fight, but it's a lot of debate.
What would be like the primary reason that someone would want to hack a private vehicle?
I can think of numerous things. For instance, one thing could be the ransomware thing, just locking your car. You can't use it until you pay me 1,000 crowns.
Yeah.
And doing that for a lot of people would have a big effect. Terrorism is another thing. If you don't have to get into the car to drive down Drottninggatan, you can just steer it with your phone or your computer. That would be another scenario. So I think there's quite a lot of cases. And then there's always these people who just want to try stuff and do stuff. So.
What's your feeling when out meeting those car manufacturers? Do they feel prepared and ready, or they see kind of their own internal maybe lack of knowledge in this area as a potential showstopper for it?
I think that at least when I talk to Volvo and Scania, I think they have more ideas of what they would like to do, but they're afraid of doing it because they don't really know the consequences. So my feeling is that they're holding back because of this, but that's just my interpretation. So I think there's a lot of things going on that they want to do. They're trying technologies and they're trying things, but they're not allowed, or they don't want to release it yet. So.
And what's the timeline of this project?
We've just started. The problem with having these partners is that getting all the agreements in place takes a lot of time. So right now it's just lawyers talking to each other, trying to figure out what that word should be in that agreement. So right now we haven't been able to do that much with Volvo and Scania, but we're doing things at KTH. So for instance, we have these thesis workers buying these dongles at Clas Ohlson and trying to find vulnerabilities. We're trying to buy a car. If you know where we can put a car that we want to hack, let me know, because that has been a problem for us. Or if I don't know, if you have students or something that could be interested in the IT part of vehicles, we're interested in that, especially if they have a background in more the car or truck side rather than the IT side. That would be interesting. Yeah, so we are doing things. So the project has started, but we haven't really gotten started for real because of agreements. So, but it's a 4-year project, so there's still some time.
Security, as the topic of your presentation, is usually thought of as vulnerability to and hopefully protection against intentional assault, intentional attack on your system. Safety either is all-inclusive, regardless of the cause, safety against any undesired events, but especially without intent, accident, if you will. But a lot of the analysis tools used by the safety discipline seems they would be applicable here. And also when we go into a specific company addressing a specific product, since several decades ago, they routinely perform reliability and safety analysis using techniques such as fault tree analysis, starting with an undesired event like collision, and then logically tracing what influences and what could by itself or in combination with other events cause that undesired end event. So fault tree analysis is one technique, event tree analysis is a different one.
Yeah, and those are very
And
similar to the things.
failure methods, failure mode effects and criticality analysis is also a different one. And often in a system with potentially grave consequences if an accident were to happen, this analysis can be quite thorough. So is now the discipline of security analysis developing as a separate discipline, or are companies using the possible synergies between these two?
Yeah, no, I think that one of the work packages in the project is looking at tool integration. So from Scania and Volvo perspective, they have a lot of tools that they're using, and they want this to be a integrated part of that tool set. So I think that we need something to analyze the kind of IT security relations and see how attacks, but I think it definitely can be related to, for instance, fault tree analysis of accidents, because this could be then a part of that analysis. So, you know, if this accident happened, could that come from, I don't know, a compromise of a certain IT part? So I think it can be related. And, you know, the fault tree analysis and, you know, some of the others that you mentioned, they're very similar. So I think it's fairly easy to relate these concepts. I don't know exactly how.
Okay, great. We are running out of time, so that's good timing. Robert, thank you very much.
Yes, thank you.